Hello everyone, welcome to the second part of the light poles and electrical wiring refactoring tutorial. So just to reiterate what we want to end up with at the end of this tutorial, this two-part series, we want to be able to connect the power source to, let's say, a battery, for instance, and it keeps charging it. The cable goes red if there is power going through the cable from the producer to the consumer. We also want to be able to connect energy providers, which can be a battery or another power source, to energy consumers. So as you can see, the light poles light up and the battery energy gets drained, and once the energy reaches zero on the battery, there's no longer energy and the light poles get nothing. So I can also connect a power source directly to a power consumer, and I can connect as well a power source to the battery, which when we have some sun hitting this solar panel, we should see this battery energy going up and the light getting on, and then as long as we reach a point where we don't have any sun providing energy to the solar panel, the battery's energy should begin to drain because it's providing power to the light pole, and as soon as it reaches zero, it should go off. Okay, so this is what we want to achieve. In the last part of this tutorial, we ended up in a state where we can connect power sources to suppliers or to consumers and to storers, but we don't get any energy going through and the cables don't light up. And at least this one should have some power because this is an endless energy source. So let's see what we are missing to make this happen. Let's start maybe with our energy consumer component. I'm just going to double check that we have everything we need here. We just need a method called receive energy that triggers that basically triggers the call on energy received. But I do want to make a tweak here. I want to make sure that the energy that comes on needs to be greater than 0 for me to trigger this, and otherwise it will mess things up in terms of the power consumers. So let's do this, and only if the received energy on the power consumer is greater than 0, we are actually going to call the on energy received. So I think that's it for this one. I don't think we need anything on event tick or begin play. Yeah, cool. So the energy consumer is done. Let's see what we might be missing. So the cable should light up when it gets some power, and I think the reason it doesn't is because I forgot to implement something, and I think that something is, let's see, probably in the plug component. So let's open that up and let's see how this is right now. Let's take a look at the event graph. I don't think there's anything I need to do here. No, we have the correct functions here. We do have the update cable caller, and I am going to make a tweak here. I don't want this cable to go black, so I don't want this branch here. I just want it to go red if there is energy, because if there isn't any energy, it's going to be the default on tick that is going to take care of that situation, which means that let me open the BP cable and I need to make sure that on the event graph, yes, it's already here. So we are already setting it to black on event tick, so actually only when we get some energy it should be red. Cool. I do think this is okay. We are creating a material instance, setting it to 0. This is just a constructor part, sending the material, creating the existing attachment if it exists. All of this is fine because when we start, oh, let me get a light pole in here just to get us started. Oh, I don't have a light pole yet. Okay, cool. So let's instead try to figure out why the cables are not getting red when we connect this guy to this guy. So there's nothing going on here. I'm going to see if the problem is the energy production component. Let's see, where is that energy production component? So yeah, we're missing a few functions here. Well, actually we have too much stuff here that we don't need actually, and we need to change it. So let's get started. I'm going to delete all of these functions because I don't really need them. I am going to do this in a slightly different way. Cables don't get updated here. We don't have any receivers anymore. Yes, we don't have any cables anymore. We do have energy production and max energy production, and we are also going to get a plug component here. So the energy production component is only going to keep a reference to the plug component that might exist on the same actor where this component is. So let's take a look at the event graph. Event graph, we don't need this anymore. We don't need these two anymore. And on the event begin play, I am going to set the plug component. I'm going to do a little discovery on the actor. I just want to try to see if we do have a plug also on the same actor. We're going to do a get component by class as per usual, and it's going to be a plug component, and if we find it, we set it to our plug component. Cool. And on event tick, I want to call a function that I'm going to create called distribute energy. And distribute energy is going to just take in delta seconds, which is a float. And this function is going to take our energy production, multiply it by delta time, so we get tiny amount of energy that we are producing this frame. It's also going to get the plug component, and I'm going to do a is valid, so only if the plug component is valid we're going to do this. And if the plug component is valid, we're going to call receive energy on the plug component, and the energy we're going to pass is the one that we just calculated. So this then we on tick, we're just going to call distribute energy, and we pass in the delta time. But this alone I think should probably already, oh, there's an error. Okay, let's see. I don't want to play. Let's nope. So it's the just had a brain freeze there. VP generator. VP generator. We have problems here. Yes, because the VP generator now it depended on some stuff that the energy production component had. So we need to make some tweaks to it. Let's see what we need to do. Okay, we have one function that we don't need, which is the setup energy receivers. We don't need this anymore. We actually don't need the energy production radius. We're not going to do any wireless energy anymore. And the components are okay. Oh, I think we need to, yeah. Oh, we already do BPI. We already implement the interface for the energy information. Yes, that's fine. Okay, so let's just focus on the functions, if they are okay or not. Let me just take a look at the event graph. Yeah, this is all wrong. I don't care anything about this part anymore. I just care about setting up the energy generated component, setting up the UI. I don't care about this part, and I'm going to do one thing, which is I'm going to call the parent function on this guy. And this is because this guy implements BP pluggable, and I do want to run the begin play from BP pluggable, even though let me check if something is being run there or not. The plug component doesn't have anything. Okay, I don't think it really needs it, but it's always a good practice to call the parent when you derive from another function, so I'm just gonna do it anyways. Oh wait, there's something wrong here. Why is this BP pluggable? Is this correct? Or am I looking at the wrong thing? Okay, I'm not opening the right thing. Let me take a look at the BP pluggable. If I can find it, maybe BP pluggable. BP pluggable event graph. Yes, okay. It actually does do something. It basically hides the selection box, the kind of green thing that we use to know what is selected. So we do need to call parent. But in any case, it's always a good idea to call parent whenever you derive something. I'm just gonna take the opportunity to take a look if this is correct. I don't need this. Oh, okay. I have the plug component, I have the selection box. I do need another function here that I forgot to implement called set plug visibility. I'm just gonna do that real quick. Set up plug visibility is just going to do, it's gonna take the selected box and set hidden in game, and it's basically gonna do this. So it's gonna start by hiding it. The set selected is okay, it's gonna do whatever you pass in, and I think now I just want to call, yeah, so I'll just, this is just for completion. I had it like this in my reference project. I think it's neater that you always do stuff inside functions, so we just do that. Cool. So now coming back to the BP generator, we do need to make some changes here. I'm just gonna go function by function to see if all is okay. So setup energy generator component, it's straightforward, so it just sets the component, and the setup UI should also be untouched because I don't think we changed anything on that. Okay, so I think it should compile now, which is what it was complaining about, and let's try to run it. So I'm gonna connect this to the battery, and there you go. So we have red, which is good, meaning that the power is going to the cables, but it's not actually providing energy to the battery. So we need to fix that. And I am going to maybe open the battery and see if that's a problem. I'm sorry about going so slow, but I need to keep checking what I did in my reference project to see if I am going in the right direction or not. So here clearly I need to do some changes on the battery. My begin play is slightly different. The class settings, yeah, this is fine. It derives from that, but I don't seem to have, oh, I don't think I need to do this actually, because we implement, oh yeah, we implement get max power and get current power. Kind of in doubt if we need to do this. Oh, we do need to do this, but I moved it into a function again to make it more clear and to be able to call parent here. So I'm just going to call parent here, and I'm going to basically extract this into a function. I think I can do collapse to function and call this setup UI. I just call it like this, and this thing just does exactly what it looks like. It just sets up the UI. What else might we need? So it's an energy container component, so let's open that one and see if something is wrong on the containers. I think the containers now also need to distribute energy, so we most definitely need to do something here. And let's see. Yes, okay, because we changed the way we receive energy, we also need to change the way we distribute energy, because the containers also need to distribute energy now. I'm just going to add a new variable here. We have current energy and max energy. I'm just going to add energy distributed per second. And this is going to be configurable. Actually, all of these are going to be configurable because I might want to set some batteries that have different max energies, like different capacity batteries, and also the rate at which they provide energy might change from battery to battery. So let's make these editable on an instance basis. Now this receive energy function, I don't need it anymore. Just going to delete it. I'm going to create a couple of new ones. One is distribute energy, which is similar to the one from the energy production component, and another is called any consumers. It's just a helper function to see if we have any consumers attached to this container. And I'm going to do energy distributed per second. I'm going to make it 50 by default, and max energy 1000, yes, and 0 on the current energy for now. So let's see, any consumers is going to be kind of a simple function. Actually, it's going to take in an input because it's going to have to be recursive, if I'm not mistaken. Yes, we have to go recursively through all the plugs and cables and plugs and cables and plugs and cables to find if we have any consumer on the end of the line. So we'll take in the start plug component where we want to start checking. And on this one, I'm going to get the cables. And I'm going to do for each. And for each cable that this plug contains, I am going to get the owner, get component by class, energy consumer component, and now I'm going to do a test is valid. So if this cable contains an energy, if the actor on the end of the of this cable contains an energy consumer, then we return. I'm gonna add a boolean for the output, like consumer connected, and make it boolean, and we return true if we do have a consumer on the end of the cable, and if not, we are going to return the result of calling the same function again, but this time, oh, actually, let me make this function pure, just so it's a bit cooler. And otherwise, I am going to do this. Oh, this is not a plug. Oh, wait a minute. Oh, PP cable. Oh, I'm sorry. I forgot a little part here. I need to get the target plug. And it's on the target plug that I'm going to do get owner. So remove this. So what? Oh, it's a different function. Yes, it's a different function. Yes. Okay. So let's see that again. So for each of the cables, I'm going to get the target plug for that, because remember, a cable has a source plug and a target plug that it connects. So I'm going to get the target plug, get the owner of that target plug, and then see if we have an energy consumer on that adapter, and if so, we return true, there is a consumer. Otherwise, we are going to get that target, and for that target we're going to ask, are there any consumers on that adapter? So it will make sure that it goes recursively trying to find any consumers through the path. And I forgot something, but it actually works for some reason. I think the default is returning false, and that's why it works, but I should put on completed return false. So if we don't find, when we finish this, if we didn't return true yet, we return false. Means we didn't find any consumers at all. Cool. So now let's look at the distribute energy. It's pretty much like the other function, more or less. So it takes in the delta seconds. I should probably try to make it generic across the production components and the container, but well, maybe. So let's take the distributed energy per second, multiply that by the delta time. This is what we're going to pass on to our consumers that we have. Let's get oh, we do need another component here. We need a plug component, and this is going to be the plug component that is set on the same actor as this energy container, because I'm going to need it to see, first of all, if it's valid, and if it's valid, I am going to call pass energy to cables on that plug component. Then I am going to, I'm going to create a local variable here called p energy to distribute float, and I'm going to set this to this value after I pass energy to the cables. I just structure this a little bit here. Okay. A little bit better, not perfect, but better. And this is the value that I'm going to pass here. You know what? Here maybe. And now I want to ask this plug component, any consumers, right? And this is going to be a branch. And this, so if this plug doesn't have any consumers attached, we don't do anything, so we don't need to pass anything. I could just return false or return basically, but if it does, then we have to set the current energy because we need to subtract the energy that we have from what we already distributed, and the way I'm going to do that is taking the current energy and taking the energy to distribute, and I'm going to do one minus the other, and I'm going to clamp this value. This is the value that I'm going to return. I'm going to clamp this value to the max energy, so it's always between 0 and max. And so we distribute the energy and then we remove that energy from our container. Basically, that's what it does. So let's see, I still need to change the event graph. Our event graph is very empty and it cannot be. So let's start with event tick maybe. Let's see if the current energy is greater than 0. Let's do a branch here. If this happens, then we call distribute energy. We have energy to distribute, so we distribute, and we distribute based on the delta seconds. Cool. Another thing we need to do before we go to take care of event begin, you know what, let's take care of begin play. Begin play is going to be just setting the plug component, and it's very simple. It's just getting the owner and getting component by class, and we get a plug component that we might have on this actor, and if we do, we set it. That's it. So now we need the receive energy event. I don't have it. On. Okay. There is something I still need to set up here. Let's see. Is this a costume event, maybe? No, this is the event from the energy consumer component. Oh, okay. I think class settings. Oh, yeah, okay. Energy container. Oh, energy container. Sorry. Energy container. Yeah. Okay. Energy container now needs to derive from energy consumer. So a container is also a consumer. It just stores it instead of doing anything other than that with it, which means that if it's a consumer, it can receive energy, so we can get the receive energy event, and we're just going to set the current energy, and we're going to set it to what? To the energy that we receive plus the energy that we already have, and we need to clamp that value because we don't want to exceed our max capacity, so we clamp that to the max energy. So now the container also receives energy, stores it, and will pass it along to any connected consumers, hopefully. Let's see if I connect this guy to this battery. Okay, nothing happens. That's disappointing. And if I connect this guy to this guy and wait for the sun, I should see a red cable, but I don't expect it to get any energy. So let's see what will happen. Dun, 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 dun. Yeah, red cable, but still no power. Okay. Let's take a look at the batteries that are on the scene. And yeah, 0, 1050, and this one is, yeah, the same. So let's start by putting this one with half the energy already. I just want to see if it's a UI problem or something else. It's not a UI problem because it has clearly some power, so it's not receiving the power. Let's see what might be wrong here. We can test this fairly easily. If we just print string here, we should see hello if we connect these two. No, we don't see it, which means it's not coming to this. It's not receiving the event. Let's take a look at our energy production components and see if something is wrong there in terms of how we are passing that, in terms of how we are passing that energy. This is all good. The plug component is receiving the energy and passing it to cables, and then passing it to consumers, which is the most important part. And this is fine. It's a receive energy on the energy consumer, and this receives the energy. If it's greater than 0, it will call on energy received, And on our event graph, oh, on energy received, and this is just the on energy received. Did I do something wrong here? On energy. Okay, I think I need to I think I'm missing a little bit of I think I'm missing a connection here between the maybe on the cable. No. I think I'm missing a connection between the function and the event. I'm just not entirely sure where. Okay, I think it should be on the consumer. Yeah, the connection is actually here. So let's print this here to see if we are receiving energy. No, we are not. So it's not even getting to the energy consumer component. Okay, that narrows it down. So let's see the energy production component. When it distributes energy, it will go to the plug component and call receive energy on the plug component. So at least here we should see something. Yeah, we are seeing something. Why? We shouldn't. Or maybe we should. Well, there's nothing generating. Well, yeah, okay. It is generating. It's always calling the receive energy on the plug where it is. Yeah, of course. Each plug on each component that is generating it, so it's receiving. So this pass energy to consumers. Let's see if it's okay, this might be wrong. Let me see. Plug component, pass energy to consumers. So it goes through all the energy consumers on the actor where we are. And let's see, print string. Yes, we are still getting here, which means that the energy consumer component should print this. And the only reason why it might not print it, yeah, the only reason why it might not print it is because if there are no energy consumers. Okay, which kind of makes sense because there are not any energy consumers, but the plug, after doing this, should pass the energy to the cables. And okay, yes, I see what's wrong. We're missing a call here. Yay, debugging. So the pass energy to cables is only updating the cable color, and it actually needs to also receive energy on the target plug. So let's get the cable, let's get the target plug where this cable connects to, and let's call receive energy on that one. And the energy we're going to receive is the same energy. You could argue here that we might want to kind of lose energy as we move along. We're just simplifying and getting all the energy that is available on the cable being passed to all the one. Yeah, that's fine. Just doing passing all the energy to all the consumers, which is not realistic, but I mean, you can make it more realistic if you want to. So let's see, the sun came up, it's starting to charge our batteries. It actually charged them really fast. So yeah, it should be working. Now, if I connect this battery to this battery, it should also power it, which is super handy. And now you can see there's power draining from the other battery, because this one is full, but the other one still keeps draining battery power as it provides battery to the next one. And if I connect this one, it's going to create like a cycle, and when the second one loses all power, it's going to start draining from this one, and it's all super cool and recursive. Cool. I think the power part is done. Let me see how we are in terms of time. I've been recording for 36 minutes, so I think we can still do the light poles, which is kind of a fun thing to do. And yeah, let's create a new blueprint. Blueprint class. Let's call it. Let's derive it from actor, I guess. Maybe not. Let's call it BP light pole. And actually, let's derive it from BP pluggable. Most of our actors that we want to be able to plug stuff into, they need to be BP pluggable by definition, and they have the selection box and all that jazz. Let's see. Let's also make it implement the BPI energy information interface, so we can provide some power information UI. Let's create some variables. Let's start with required energy float, and let's create another one, max intensity, and another one, current energy, and another one, current intensity. These are all control variables. What else do we need? I think I need a reference to a bunch of other stuff, so I definitely need a component for the let's see, for the energy consumer. Yeah, I need an energy consumer component on the pole. The pole is going to consume energy. I don't think I need to do anything special on this thing. Now I also need a widget so I can show my power information. I'm going to call it capacity information. And this I need to do some tweaks. It's going to be a screen. It's going to be the WPP power bar. And it's going to get like 50 by 10. I'm just copying from the other widgets. It's no big deal. And okay, what else do we need? The interfaces, we need to implement those get max power and get current power. Get max power is going to be the max intensity. Yeah, just want to see how intense the light is. I'm just cheating. I'm not actually showing power, I'm showing intensity, but you know, you can use it for whatever. And this is going to be the current intensity. Did I make a mistake? Max power, max intensity. Yes. Okay, cool. What else do we need? So we're going to have some functions. Actually, we're only going to have one function, but let's build the thing before. I'm going to add a static mesh component here. Let's call it pole. And it's going to be a cylinder. 0.2, 0.25. So 5 meters high and 20 centimeters, 40 centimeters of radius, well, 20 centimeters of radius, 40 centimeters of diameter. What else do we need here? I think that's fine. I don't need anything else. Well, let's just do a basic shape material, just to be white. Now let's duplicate this guy and call it arm. I'm just going to nest it with pole, so it's going to be a child of pole. It's going to have a few things changed, like 270 on the Y, 45 on the Z or Z, depending where you live. 100, it's like 1 meter, and then we scale it by a little bit just to make it kind of a tiny arm on top of the pole. Cool, gets the same properties, it's all good. Let's duplicate that guy. Do I want to duplicate? Yes, I do want to duplicate. I'm gonna call it cone, nest it with the arm, and the cone is going to be, let's see, 66.67, 42.8. These are just the values that I came with. You can change them. Minus 100, and then 2 by 2 by 0.2. So we get kind of a, oh, I'm sorry, I need to choose a cone, not a cylinder. Yes, perfect. So as you can see, we have something that kind of resembles a street light. Kind of. It's all good, all good. So now let's add a point light. Nest it with the cone. Actually did it by default, which is fantastic. And now we just change some of the settings here. Let's see, minus 60 on the Z position. Rotation doesn't really matter, but let's make the scale 25, so it's pretty big. And yeah, I'm gonna just put this small tiny value here. I don't think it makes that much of a difference. Yeah, it doesn't. It's just 0. Don't mind me. Okay, so I want to change the intensity to 0 by default, so there's no light, it's out by default. And yes, so I think it's all good in terms of what we need for the blueprint. Now we do need one function called setup UI, and this function is going to be fairly simple. We are going to get the capacity information, get user widget object, and cast to WPP power bar. There you go. And then we set set actor. I think that's a function from, okay, I might be mistaken here. Oh, okay, as WPP power bar actor, we set the actor, and we set the actor to a reference of self. So we just tell the widget that we are the actor that needs to report information about the current power, or in this case intensity, and the maximum power or intensity. Cool, so I think we just need to go to the event graph and set up things. Let's see, there's a bunch of stuff to set up actually. One of the things is I don't need this begin overlap. I do want to call the parent on the begin play because all BP pluggables should call the parent. Then I want to call setup UI. Cool. And then I want to get my energy consumer component and I want to do bind event. Oh, if I can type, bind event to on energy received. So we want to be notified when we receive some energy. Okay, and I'm just gonna drag this thing, and I'm gonna create an event. Sorry, my bad. I want to costume event. You can leave it blank, it doesn't really matter. You could call it on energy received, so that would be fine. And now we are plugged into the receive event, which means we can do a bunch of stuff. But before we do, I want to go to event tick and finish this one off because it's fairly simple. I want to get the current intensity, not energy, and I want to check if it's bigger than 0 and do branch on that. Okay, and now if the current intensity is greater than 0, I want to set it to 0. Okay, might sound strange, but what I want to do every tick is turn off the lights basically, and then as we receive energy I turn them back on again. So it's the way to keep the light always off unless you are actually receiving some energy, which kind of makes sense. And I'm just going to set this to be 0, but I can set it like this. Cool. I don't need to worry about that part anymore. Event tick is dealt with. Let's go down here. So now what we do when we get some energy? Well, first thing we do is set the current energy. Right? We set the current energy to whatever energy we are receiving. Then we are going to do some calculations to calculate the current intensity. And it's kind of simple. I'm just going to divide the current energy that I receive by the required energy to light the light, basically, which kind of reminds me, let's set up the defaults for this. So required energy, I'm going to put a 5. I don't care about the units, they're just they're just how are you called, simulation values, so they don't need to be accurate or anything like that, even though they can be if you want to. And current intensity and current energy, they just remain 0. So the required energy, we divide the current energy by the required energy, and then we multiply that by the maximum intensity. So we're trying to figure out in percentage if this energy, how much intensity does this energy will give us. Basically that's what we're doing here, and I'm going to clamp this value to the max intensity, so we never overshoot the max intensity we can have, and then I'm going to set the current intensity to that value. Okay, and then I'm going to do the same I'm doing here. Basically I'm going to set the intensity on the light to my new intensity. So now hopefully if I can get some poles in here, do I need to change, let's check if I need to change the reference where these guys are. If I did something special to put it at ground level, I probably did. Let me just see the BP pole. No, I don't think I did. I probably just dragged them. Oh, or I did. Wait, I did do something. What do I need to do here? I probably need to move the pole very high, which I didn't. Let me see. The pole is actually, yeah, it's actually 250 from the ground, so 2.5 meters, which is half of our height. Yeah, perfect. So now you can position it on the ground level, which is much better. So let's just duplicate this guy real quick. Actually, triplicate it. And let's see what happens here. So it's all off. If I drag this guy and connect to this pole, there's a light. Fantastic. and it's actually draining from the battery, and you can see it's not very powerful, and it should go off. It is off. So now let's connect this power source to this guy directly. There's much more light here because now we can see that it's actually getting the 5 that it requires, which makes it max intensity. And if I connect this guy to this guy, yes, I get like a chain of energy being produced and passed along, which I can also connect to the batteries and make sure that everything is like connected together, and then everything is perfectly working and spreading power in the world. So there you have it, guys. I hope you liked it. This basically allows you to do pretty much anything with energy that you can think of. You can connect things endlessly and then just plug in power wherever you want. So I hope it helps your projects, and next tutorial I'm going to think about something else to do. So until next time, I hope you enjoyed, and talk to you later.